Okay, ladies and gentlemen, so this is our extra bit of practice on dimensional analysis. So if you're here right now, maybe you're struggling a little bit with how to set up conversion factors or how to really use this process to answer metric conversion questions. Now, it's very important that we do master the skill because I promise dimensional analysis is going to come back big time later in the year, so you might as well get it now instead of struggling with it later. Now, with the sheet that I've created for you, which you hopefully have printed off or are looking at somehow, I want you to take a look here at the table that I've included for you. It's table C right from your reference table, and it includes everything that we need to know in order to convert from metric unit to metric unit. All right? Now we've got the symbols, we've got the prefixes, and we've got the conversion factors. And as we go here, I'm going to write a couple of things on this table C, and they're things that I want you to write on there too. All right? They're really going to help you and make sure that you've got them down. They won't be on your table C when you take a test, but if you've written them enough times and you've seen them, hopefully you'll remember that they should be there. All right? Now, if we take a look at the bottom of table C, I also have something else written for you as a really nice reference. When we do dimensional analysis, we always follow the same basic principle. All right? You start with what you're given. You start with the first thing that you have, and then you say, hey, that's the only number that's in my problem. Write it down and include the unit. All right? The next thing that you have is going to be the conversion factor. All right, so when we're dealing with the conversion factor, it's essentially a fraction that we write in order to find our way between our given unit and our desired unit. So it's a way to cancel out the unit that we're given and end up with the desired unit that we have. Okay, so this is the format that we'll follow, and we're going to use this throughout each one of the problems that you see to the left. All right, so if you follow me back over to the side here, let's get rid of this guy. We're going to see our questions. So the first one that we have is pretty simple. I'm pretty sure I've done this exact problem in class, but we're going to try it again because it's a really good way to make sure that we understand exactly how the dot line method kind of works for this. So I'm going to set up my given. So the thing that I'm given in this case is going to be that 10 meters. And so the 10 meters I'm going to start and write down. And then we're going to go dot, line, equal to, leave a space for my answer, and I already know that the unit that I desire is kilometers. All right? So now if I'm taking a look at what this structure really means, this piece right here, this piece where I have this empty fraction bar, that's where my conversion factor is going to belong. So before I deal with any numbers, I'm going to deal with my units. So I'm going to think to myself, hey, the unit that I'm given is meters. The unit that I want is kilometers. The unit that I want to end up with goes on top. I want to end up with kilometers. The unit that I'm in that I want to cancel out is meters, and so it goes on the bottom. So we're halfway there right now because those units are a big deal. Because once we've figured out that those units are in play, we can then go over to table C. And so table C is going to tell us a lot of information. Because I know I'm dealing with kilometers, I'm going to be dealing with kilometers right here. So I'm going to deal exclusively with the top thing. Now, for table C, we're going to make a couple of edits right now. We're going to make a couple of notes to ourselves, and we're going to use it throughout our time here. So, in front of each one of the prefixes, I want you, if you haven't already done so, to write a 1 in front of each one of these prefixes. Because how I need you to read this table is 1 kilogram or kiloliter or kilo whatever metric unit is equal to 10 to the third of the base unit. In this case, we're dealing with meters. It could be grams, okay? It could be liters, but of the base unit. So 1 kilo is worth 10 to the third of the base unit. 1 deci something is worth 10 to the first of the base unit. So I'm going to put meters down again. So 1 centimeter is 10 to the negative second of the base unit. So 10 to the negative second meters. And that's how we read this chart every single time for these conversion factors. So for us in this question, what we need to say here is how many kilometers is equal to some number of meters. And so what I need to know here is 1 kilometer, which is what I'm reading it here, is 10 to the third meters. And all I do is place that in my conversion factor. 1 kilometer, 10 to the third, make that a 3 meters. Okay, so we're more than halfway there now. We've just got to solve it out. If you have a graphing calculator, this is super easy. Since we are only allowed to use scientific calculators, it becomes slightly more difficult to wrangle with the exponents, but 10 to the third actually comes out to 1,000. You could know that off the top of your head. You could go 10 times 10 times 10, or you could plug in 10 to the third into your calculator. Regardless, you are essentially going to do 10 divided by 1,000, and the answer you get is 0.01 kilometers. All right, so as we take a look down at number 2, we're essentially going to do the same thing. So we're going to set it up. We're going to start with our given, which is 2 kilometers. And this time we're going the opposite way. Dot line is equal to meters. Instead of going from meters to kilometers like we did in the first part, we're doing kilometers to meters. So once again, first thing I do is place my units. I want to end up in meters, so they go there. I want to cancel out my kilometers. They go on the bottom. So now I need to go back to table C, and I need to say, okay, 1 kilometer for every 10 to the third meter. So then I write that in. 1 kilometer for every 10 to the third meter. And so now instead of dividing by 1,000 like I did above, I'm going 2 kilometers times, this is 1,000. So now I have 2,000 meters, which makes sense. 2 kilometers is equal to 1,000 meters, or 2,000 meters. A meter is smaller than a kilometer, so it makes sense. Check. If it doesn't make sense to you, maybe you did something wrong. All right, number 3, let's take a look at it. 250, okay, milliliters, dot line is equal to, and we're going to liters. So I want to end up in liters, and I want to cancel out milliliters. Okay, so now let's deal with something else, milli and liters. So I see milli, and I say 1 milliliter is equal to 10 to the negative third liters. So let's say that again. 1 milli is 10 to the negative third liters. Okay, so as I take a look at this, maybe you don't know what 10 to the negative third is, so I would say definitely put that into your calculator individually if you don't know. So when I do this, 10 to the negative third is 0.001. So that's moving our decimal place to the left 3 places. Okay. So then I'm going to multiply through. I have 250 times 0.001, and my answer is 0.25. Okay, as you seem to be getting the hang of this, I'm going to ask you to work on 4 and 5 yourself. See if you can set them up appropriately. And when you'd like to see the solved answers, please unpause me and you can check them. Okay, so as we take a look at 4 and 5, we'll see a couple of interesting things. Number 1 is that we can check and see if our units make sense. So if we look at 4, we start with 2,000 grams, and then I have my units set up with kilograms on the top and grams on the bottom. That means that grams and grams cancel out, leaving me just with kilograms as my unit, which is exactly what I want. Then I see that 1 kilogram is equal to 10 to the third grams, which is exactly what I should get from the table. And I do get 2 kilograms as my answer. Now for number 5, we can check our units in the same way again. I start with meters, and I want to end up in centimeters. So meters cancel with meters. I'm left with centimeters on top. Great. All right, now my conversion factor seems a bit odd. I have 1 centimeter and then 10 to the negative second meters. Now there's a couple of ways you can solve this. You can remember from math class that a negative exponent flips positive on top. So that's a quick way to solve this in your head. That really means 23.2 times 10 to the second, which is really just times 100. And that's how you could get this without a calculator. Or you could just divide it by 0.01, which is essentially what this is. And we'll get the same answer. Alrighty, so hopefully you were successful. So let's take a look at 6. I'm going to ask you to try that one yourself. Make sure you can do it. And then unpause me when you want to see the answer. Alrighty, so take a look at number 6. You can see that again our units check out. Meters cancels with meters, kilometers on top, and this follows our lovely conversion factor from up there. 105 divided by 1,000 does equal 0.105. Alright, number 7. If you've successfully mastered the one-step conversion factor, then I have a challenge for you. And that challenge is number 7. And that challenge is going between 2 non-base units. Every single one of these questions, and most every question you will ever see from me or on a Regents exam, will go from one metric unit back to the base unit, or from a base unit to another metric unit. It will never go from a non-base unit to a non-base unit, except when I'm giving you a challenge. So we can see that this can be done, which is really why we like dimensional analysis and why we're going to continue to use dimensional analysis, because you can go from unit to unit to unit without breaking pace. It just takes a couple of extra steps. Still the same process, however. So we can go through this together. I'm going to start with my given, 23 kilometers, and I have to go back to the base unit. I can't just jump right to centimeters, because guess what? My table up here doesn't say anything about kilometers to centimeters. That doesn't exist. I can't do it. It just doesn't work. I only have kilometers to a base unit and then a base unit to centimeters. And so that's the step I'm going to take. It's the only path I have. So I'm going to take my kilometers, my given, and I'm going to say, okay, I can get to my base unit, and I can get to my meters. And I can say, okay, 10 to the third meters is 1 kilometer. My kilometers cancel out. Great. I'm left with meters. But I don't want meters. I want centimeters. So I'm going to do another dot line. And I'm going to say I don't want meters. I want to cancel meters. And I want to end up in centimeters. How do I get from meters to centimeters? I'm going to go back up to my conversion factor, and I'm going to take a look. And I'm going to say, okay, 1 centimeter, 10 to the negative second meters, and head back. And say 1 centimeter, 10 to the negative second meters. And I'm done. I know I'm in my centimeter unit. I just need to multiply everything across and divide by what's on the bottom. And when I do that, I get 23 times 10 to the third divided by 10 to the negative second. And my final answer is this guy right here. Now, hopefully that's what you got in your lovely calculator. Alrighty, hopefully this helped you, and let me know if you have any other questions when you come on into class.